We are looking at this question to find the area of the region enclosed by the curve y equals to 1 plus cosine of x and the line y equals to 1. First of all, we need to actually find out the point of intersection between the curve and also the straight line. So the first step will be letting 1 plus cosine of x equivalent to 1. Hence, you will be able to get cosine of x equivalent to 0. So in this case, x will give you, pi over 2. Considering that it is also at the negative side of the curve, hence this particular point will be equivalent to negative pi over 2. The next step that we are going to do is to find the area under the curve. So if you are integrating, the equation of 1 plus cosine of x dx from negative pi over 2 to pi over 2, the area that you will be getting is basically the area under the curve which is bounded to the x-axis, this whole particular part. Alright, so hence, now with this, we will proceed to find the area which is bounded to the x-axis. So from here, when you integrate, you will get x plus with sine of x with the correct limits. Next step is proceed with substitution, pi over 2 plus with sine pi over 2 minus with the substitution of negative 1 pi over 2 plus with sine of negative pi over 2. Continue with this, getting the value from the calculator, pi over 2 plus with 1 minus negative pi over 2, so it becomes positive, so plus with 1, because this particular part is giving you negative, hence negative multiply with negative 1 will give you positive. Alright, proceed with this, you'll be getting pi plus with 2. Hence, this is the area under the curve which is bounded to the x-axis. However, the shaded region that we want, is only the top part. So we must remove, this particular area, which is you can see as a rectangle. If you note that, this distance from negative pi over 2 to pi over 2 will be equivalent to pi, and then the height of this rectangle is equivalent to 1. Hence, the area of the rectangle is equivalent to pi base times height, so it is equivalent to pi. Right? So to get the area of the shaded region in between, so all you need to do is you take the area under the curve, so shaded region, will be equivalent to pi plus 2 minus the area of the rectangle to get 2. That's your final answer. We will now proceed to the next question. Find the area of the region bounded by the curve y equivalent to 2 plus 3x minus x squared, with the line of x equals to 2 and the line y equals to 2. From here, you have all the limits given. So what you need to do is, you can first find the area under the curve from 0 to 2. So let's move on to find the area under the curve, where you take integration from 0 to 2, 2 plus with 3x minus x squared dx. From here, you will be able to get 2x plus with 3x squared divided by 2 minus x to the power of 3 over 3 with the limits from 0 to 2. Continue to substitute the limits in the equations in your integral. So you will get 2 times 2 plus with 3 times with 2 to the power of 2 divided by 2 minus 2 to the power of 3 divided by 3, and this whole thing, after substitution of 0, you are getting 0. Okay, with this, okay, after substituting all the values in the calculator, you should be able to get 22 over 3. Okay, but this area that you are looking for is actually the area under the curve which is bounded to the x-axis. Okay, so now you want only the one which is shaded, so we must remove, okay, the area of the rectangle. Okay, so in this case the base is 2, the height is 2, so the area of the square, I'll say, because both the sides are the same, so the area for this quadrilateral, okay, will be equivalent to 4. So the area of the quadrilateral will be equivalent to 4. Hence, the shaded region, okay, the area of the shaded region can be found by taking the area under the curve minus the area of the rectangle, and you will get the final answer as 10 over 3. This is question number 3. Find the area of the region bounded by the curve y equivalent to 3x squared plus 2 with the line of y equals to 14 and y-axis. So in this case, as you can see, there is a coordinates given where y is equivalent to 14. So when y is equivalent to 14, there's one value that we can find, which is x. So letting 3x squared plus 2 equivalent to 14. Okay, solving this, 3x squared will be equivalent to 12. Okay, 12, and then x will be equivalent to 12 over 3, then you get 4x will be equivalent to plus minus 2. But in this case, it should be positive. Hence, x is equivalent to 2 here. Alright, with this information given, you can basically find the area of the whole quadrilateral here, the whole part. Okay, it is a quadrilateral where you can find the area by multiplying the base with the height. So I take 2 multiply with 14, so the area is 28 for the whole diagram. To continue with this, okay, so I need to actually find out, okay, what is the area which is bounded, okay, between the curve and the x-axis. To get this area, okay, what I can do is to integrate this equation of the curve. So let's proceed to integrate the equation of the curve. So now, integration of 3x squared plus 2 dx with the limits of 0 to 2 to find the area under the curve. So getting the correct integral, 3x cubed over 3 plus with 2x, putting the correct limits. Alright, simplify. Okay, you will be getting x cubed plus with 2x with the limits of 0 to 2. Okay, substituting the values in the equation, so you will be getting 2 to the power of 3 plus with 2 times 2. Okay, putting 0, you will get the whole part as 0. With this, you will be able to get your answer as 12. Alright, so to get the area of the shaded region, all you need to do is you take the area of the quadrilateral, okay, which is this whole part, okay, quadrilateral, minus out the area under the curve bounded by the x-axis. So 28 minus 12. Hence, your answer will be 16. Let's proceed to look at the last question. Find the area of the shaded region. So first, limits are given from 0 to pi over 2. So to find the area under the curve, which is bounded by the curve and also the x-axis, so all we need to do is integration of 0 to pi over 2, okay, to pi over 2, to sine of 2x plus with 3 cosine of x dx. Integrating this will give you 2 negative cosine of 2x, okay, divided by 2 derivative of 2x plus with 3 sine of x with the limits of 0 to pi over 2. Let's proceed to simplify this and this. So what you will be getting is negative cosine of 2x plus with 3 sine of x with the limits of pi over 2 and 0. Moving on to next, substitute the value in the equation where the first part, negative cosine, after you have put in pi over 2, you should be able to get pi plus with 3 sine of pi over 2. That's the first part. Minus the substitution of 0. So negative cosine of 0 plus with 3 sine of 0. Continue with this. Cosine of pi is giving us negative 1. So hence, negative times negative 1 plus with 3 times with 1. Sine of pi over 2 is equivalent to 1. Minus negative cosine of 0 is giving you 1 plus with sine of 0 is giving you 0. Hence, to simplify this, you will have 1 plus with 3 plus with 1 here. So hence, it is 5. This area that we found here is the area under the curve for this whole part. Okay? But what we intended is only the one bounded by the line and also the curve. Hence, we must get rid of, okay, the triangle. Okay, we must get rid of the area of the triangle. So to find the area of the triangle is as simple as you using 1 over 2 times base times height. So to find the area of the triangle, okay, so the area of the triangle is equivalent to half times width. The base is pi over 2. Pi over 2 multiplied by 3, the height. So hence, you'll be getting 3 pi over 4. So lastly, to get the area of the shaded region, okay, all you need to do is, you just take 5, okay, area under the curve, minus the area of the triangle, 3 pi over 4. So that's your final answer. So hope you find this video useful. Thank you. Bye.